Today we're going to talk about completing the square. Completing the square is a method of factoring into a binomial. And what we want to do is make it a perfect square binomial. So if I'm looking at this example, x squared plus bx plus c, and I want to make sure this factors into a perfect square, the only way this will be a perfect square is if the c value, so as if c is actually equal to half of b, so b divided by 2 squared. If c is half of b squared, then I can make a perfect square binomial where this x squared plus bx plus c would factor into x plus half of b in parentheses squared. And that would be a factor, the x squared plus bx plus c factored. So let's try an example or two. So if I'm looking at this x squared plus 4x plus c, and I want to write the expression as a square of a binomial, I need to come up with a c value that'll make this a perfect square. The way to make the way to make x squared plus 4x plus c be a perfect square is to make the c value be half of b squared. So I look up here, b is actually 4. So the c value is 4 divided by 2 squared. 4 divided by 2 is 2. 2 squared is 4. So if I have the expression x squared plus 4x plus 4, this is going to be a perfect square. And the way you write that perfect square is just write x plus 2 in parentheses squared. I know it's going to be x plus 2 because right here is the half of b number in the parentheses from above, and that would be what this factors into. So now if I look at the next one, I have x squared plus 9x plus c. I need to come up with a c value that'll make this a perfect square. In order to do that, I got to figure out what half of b is and then square it. So in this case, b is 9. So I want 9 divided by 2 squared. So 9 divided by 2 is 4.5. Squared is 81 fourths. So if I wanted to make this a perfect square, I would write x squared plus 9x plus 81 fourths, and that would factor into x plus 9 halves squared. And that would be the perfect square, x squared plus 9x plus 81 fourths. Let's actually solve an equation using completing the square. So normally when we solved equations, we always wanted to make it equal 0 like this one does here in example A. But now when we're completing the square, I'm going to go ahead and add 4 to both sides to get this out of the way. And what I have is x squared plus 6x, and that equals 4. Now I left a blank here because this blank, I actually want to add some value in. I want to add a number that's going to make this a perfect square. So what I'm going to do is add a c value. Whatever I do to the left side of the equation, I must also do to the right side. So whatever c is, I'm putting it on both sides. So I get c by taking half of b. So c equals half of b, which is 6. b is 6 here, divided by 2 and squared. So c equals 3 squared, which is 9. So I'm actually adding 9 to both sides. So I got an x squared plus 6x equals 4. And I'm adding a 9 to the left side and to the right side. Now, the thing about x squared plus 6x plus 9, it is a perfect square. That perfect square is x plus 3. I know it's going to be x plus 3 because that's what I got in the parentheses when I took half of b. So then that is squared, of course, equals, well, 4 plus 9 is 13. And now I just solve the equation. To solve this equation, I get rid of the squared. So I square root. And when I square root, the square and the square root will cancel out. So I get x plus 3 equals, and at this point I took a square root, which means I got to have a plus or minus radical 13. And now I just got to get rid of that 3 by subtracting. And when we subtract 3, we get x equals negative 3 plus or minus radical 13. And that is our answer. Let's try the next one. So it's going to be the same thing. So the first thing I want to do is add 5 to both sides. And I get x squared minus 3x and then equals 5. So at this point, I want to add a number to both sides, and I'm going to add c to both sides. The way I get c is just take half of b, which is negative 3 over 2, and square it. So negative 3 over 2 squared is 9/4. So I'm actually adding 9/4 to both sides. And then everything else stays the same. So it's x squared minus 3x plus 9/4 equals 5 plus 9/4. Now I know that this x squared minus 3x plus 9/4 is a perfect square. It is going to factor into x minus 3/2. I got the minus 3/2 because that's what it is, half of b. See, b is negative 3, so half of that always goes here. And then squared equals, well, 5 plus 9/4. I can make 5 a fraction as 20/4. That's just 5. 20 divided by 4 is 5. Plus 9/4. That's going to give me 29/4 when I add 5 to 9/4. So at this point, I have a squared, so I got to take the square root to get rid of it. So the square and the square root cancel out. I get x minus 3/2 equals, well, the square root of 29/4 means I square root the 29, I square root the 4. Square root of 29 is the square root of 29, square root of 4 is 2. But every time I take the square root, it's got to be a plus or minus. So it's the square root of 29 over 2. And my last step would be to add 3/2 to both sides. And when I add 3/2 to both sides, I'm going to get x equals 3/2 plus or minus radical 29 over 2. And that's the answer for x. So let's try letter C. So the first thing I want to do again is subtract the 2 to both sides. So we get an x squared plus 8x, and that equals a negative 2. And at this point, I'm going to add a c to both sides. And that c that I'm adding is going to be the same thing. I get that c by taking half of b, b is 8, divided by 2, and squared. Half of 8 is 4, 4 squared is 16. So my c is 16. So I got x squared plus 8x, and add 16 to both sides. So now I know this x squared plus 8x plus 16 is a perfect square. It is x plus 4 in parentheses squared. And I got the 4 right here. It's half of b. b is 8, so half of that is 4. It's always squared. Equals, well, 16 minus 2 is 14. And now I just solve the equation. And when I solve, I take the square root, take the square root. Square and the square root cancel out, so I get x plus 4 equals plus or minus the square root of 14. And then, of course, the last step would be to subtract 4. And I subtract 4 to get x equals negative 4 plus or minus the square root of 14. And that is how I use completing the square to solve a quadratic function. Now let's take a look at the next one. The next one says I want to write it in vertex form. Vertex form is y equals a times the quantity of x minus h in parentheses squared plus k. So that's what I want this equation to look like. What I have it in is in standard form. So this equation is in standard form, and I want to change it into vertex form, which is what I have above here. So in order to do that, I have to complete the square. So when I complete the square, I'm going to write down this y equals x squared minus 10x. I'm actually going to leave the plus 4 on this side, but what I want to add is a c value to both sides such that this is going to be a perfect square. So that perfect square is going to be half of b squared. b is 10, so it's actually x minus 10 divided by 2 is 5 squared. And this plus c value that I added is actually 5 squared, which is 25. So y plus 25 equals x squared minus x minus 5 in parentheses squared. So I add 25 or subtract 25